Hello dear friends, welcome to our program for Science 3rd Prep Stage. Today we have a new information, a new lesson about what? About nuclear energy. What are the harms? What are benefits of this type of energy? What are dangers of these things? Today we have a very important lesson to know many information about the nuclear energy. This one is very important. Listen to me carefully and start to go this one to study this very well. Let's go to start our lesson. Today we have electric connections. We will talk about the electric connections and its type. But first we have what? We have the relation of Ohm. That's we have what? We have R equal V divide I. First thing we have what? We have the relation between resistance, voltage, or the potential difference, and what? And we have the electric current intensity. Here we have the resistance equal what? Equal voltage divide the current. What's meant by voltage? Potential difference. It's symboled by V. And we have the current. It's symboled by I. So here we have R equal V divide I. And this one, we have the resistance here. It's from Ohm's law. And the voltage here equal what? Equal current times resistance. But here we have the voltage is equal I times R. V equal I times R. So here this is what? This is the mathematical relation between V, I and R in what? Or according to the Ohm's law. Here we have the Ohm's law. We have formula triangle. This is what? This is V and this is R and this is I. So here we have V. It's what? It's the potential difference. And we have R. It's what? It is the resistance. And I. It's what? Electric current intensity. Very good students. You remember this. So here we have the V. If I need to calculate V or potential difference, hide it with what? With your hand like this. And V equal I times R. Why? Because here we have what? We have the I and R. It is on one line here in this triangle. They are below V. And if I need to calculate the I, hide the I by your hand and we have V divide R. This is what? This is V in the upper part of this triangle and we have R. Concentrate very well here, because if you put any symbol replaced by another one, so it is wrong, completely wrong. Why? Because V equal IR here, and here we have the R. Last time we have what? We have R. If you need to calculate the R, it's V divide I. It's very easy to make this. Why? Because here this one or this is the mathematical formula of what? Mathematical formula of what? Of Ohm's law. After that, from Ohm's law, we can define the following. Can define what? We can define the resistance. We can define the electric current intensity. We have ampere. We have many things that we use it to make what? To make these definitions. Resistance of the conductor R. It is ratio between potential difference across the conductor and the current intensity passing through it. Because R equal V divide I, it is a ratio. It is a relation between them. So here we have R. If you have a question here, we have define R or the resistance according to Ohm's law. It's what? The ratio between potential difference across the conductor and the current intensity passing through it. And after that we have another definition that's called Ohm. Here we have the Ohm. It means what? It is the resistance of the conductor which allows the passing of electric current intensity of 1 ampere when the potential difference across its terminals is 1 volt. So here we have what? We have 1 ohm, or the ohm is the resistance of the conductor which allow the passing of an electric current intensity of 1 ampere when the potential difference across its terminals or ends or 2 points in the conductor is 1 volt. After that we have the ampere. What's meant by ampere? Ampere It is the current intensity passing in a conductor when its resistance is 1 ohm. And the potential difference is 1 volt. Again, we have ampere. It's the current intensity passing in a conductor when the resistance is what? Is 1 ohm. And the potential difference here, it's across the terminals or between two ends of this conductor is 1 volt. After that, we have the volt. This volt, it means what? It means it is the potential difference across the terminals of a conductor when the resistance is 1 ohm and the current intensity passing through it is 1 ampere. So it is very, very important things to know this definition to make what? To make your exam high marks. So here we have the volt, we have definition of volt, we have a definition of resistance, ohm, and what? And the electric current intensity or ampere. After that, we have some questions about what? About voltage, current, and resistance. We have the voltage here, it's current times resistance. To start to begin, here we have what? We have a current of 5 amperes flow through what? Through a coil of a wire when the potential difference across it is 230 volts. What is the resistance? Here we have 5 amperes and here we have 230 volts. What will happen here? I need to calculate this one. Which one here? I need to calculate the resistance. I need R. What's R? R equal what? Equal A divide or I divide V? No. It's I times V. No, it is wrong. Why? Because here we have R. It's what? It is V divide what? Divide I. So here V divide I, 230 divide 5, it's equal what? It's equal what? Which one of them? Yes, this one is right. It's 46. Why? Because the resistance here equal voltage divide current or V divide A. So here we have 46 ohms. Don't forget this one, ohms. Why? Because you have half mark on this unit in your exams. I have next one. We have the potential difference of 5 volts. 5 volts. We have V equal 5 volts applied to the resistor or 1 kilo ohm. What's meant by kilo ohm? It's 1000 ohm. So here we have 5 volts and R here 1000 ohm. Which one is right? Which one? Yes, this one. Yes, very good. Why? Because here we have 5 amperes divide 1000 ohms equal 0.005 amperes. It is not this one and not this one. Another one. We have what is the voltage need to pass current of 0.1 ampere through what? 10 kilo ohms. It's very big one, mister. Yes, it's found, really, it's found here in some kind of stations. We have high resistance and we have high electric current intensity that reaches mega ampere or mega volt. So here we have the potential difference by megavolts or gigavolts. So here we have the voltage needed by pass current 0.1 ampere through a 10 kilo ohm resistor. This resistor or resistance here, we have V, we have I, and we have here R. I times R. So 0.1 times what? Times 1000. It's which one of them? Which one of them? 0.1 ampere times 10,000 makes what? It makes 1000 or 100? No, it's 1 kilovolt. Yes, very good. 1 kilovolt here because it's what? It is 1000 volts. Why? Because the current times resistance equal voltage. So here 0.1 times 10,000 ohms, it's equal what? Equal 1000 volts or 1 kilovolt. Here we have the electric connections now. What's meant by electric connections? First of all, we have what? We have two types of connections. Connections of what? Connections of the devices that we talk about it, like a meter, voltmeter, and resistance or rheostat, and the battery. By what? By the wires. So the electric conductors or electric connections here, we have first type is what? Is first type is series connection. What's meant by series connection? It's the negative pole of the first cell is joined to the or connected to the positive pole of the second cell, and so on. Again, we have the series connection. It means what? It means the negative pole of the first cell. We have many cells that connect to each other, many dry cells to connect to each other, that joined to positive pole of what? Of the second cell, and so on. Like this. We have a circuit here. This is the circuit, and it contains a battery that has what? That has 2 volts. And here we have what? We have the cells. This is what? This volt. If I close this one like this, or this key, we have 2 volts that makes the light of the lamp. But if I increase this number of cells like this, so it is called series connection. Why? Because here we have positive, negative, positive, negative. Again, we have positive here in the first one that connected to the negative one, and the negative one connected to the positive one of the second one. If I increase these batteries like this, we have 3 batteries, and here we have what? We have the electric charges, or the voltage of each one of them is 2 volts, so the total is 6 volts. It's very high voltage. So if I close this key or turn on this lamp, it will light up more than the first case. And here, if I have the first one of these batteries, and I make this closed one, or close the key here, and I have a meter to what? To calculate or to measure the electric current intensity. So I have here 0.3 ampere. Here we have 2 ammeters here, 0.3 ampere. And if I have increasing the cells like this, I have 2. What will happen here? If I increase the voltage here in these 2 in series connection, we have what? We have, and I close this one, we have increasing in the electric current intensity that pass. And if I increase the cells again in last time to what? To the 3 cells, so here we have these 3 cells, the total is very high, so we have the electric current intensity will increases to 0.9. What will happen here? Here we have the series connection. Negative pole of the first cell that connected to the positive pole of the second cell, and the negative pole of the second one connected to the positive pole of the third one, and so on. So here we have what? We have this is series circuit or series connection of batteries. And if I have the voltmeter here, this voltmeter is what? Is 6 voltage or 6 volts. Why? Because here we have what? We have this one. The voltmeter is 6 volt. If I decrease the cells here, we have decreasing in the voltage. So here we have, if you close this or turn on the key, so here we have, this is 4 volts, 2 plus 2, it's equal 4 volts. The total number of this one in series circuits. So here, if you put the bulbs like this, 2 like this, and here we have the 2 voltmeters here, so this one, it's what? It is connected to each other like this. Again, we have what? We have 2 lamps here. If you increase the lamp, so the electric current intensity that decreases like this. And if you have 1 lamp like this again, and close the key like this, and make the cell decreases to 1 again, so here we have what? We have here, this is 2 volt for this battery, and we have the electric current intensity 0.3 in each one of them. After that, to measure the EMF of what? Of the group of the cells connected in series. What's meant by EMF? It is the electromotive force. What's meant by electromotive force? It is the voltage that found inside the batteries or inside the cells. So here the E1 or E total, it means what? It means the energy or the voltage that found in all batteries that we have, E1 plus E2 plus E3. And here we have the total one equal E1, E2 plus E3 plus any number of what? Of the batteries that found, or any numbers of cell that found in this circuit. The EMF of dry cell are equal. So the E total, if the EMF of each one of these dry cell are equal each other, so here we have they are equal, so the E total or the energy or the voltage, total voltage of this cell or this battery equal what? Equal N times E1. So this one, where N is what? Is the number of dry cells. Here, if I have 5 dry cells or 3 dry cells that found in this circuit, you have each one, it's 2 volts. What will happen if I need to calculate the total EMF? It's equal 3 times 2 equal 6. And after that we have the second part, or the second type of connections. We have parallel connection. What's meant by parallel connection? Parallel connection here, it means what? It means the positive pole of all dry cells or all parts or all devices that joined together, and the negative pole are joined together in one point or one end, and the total EMF of each one of these batteries, or the total EMF of these batteries all together, it's equal EMF of one of them. Why? Because they have what? They have one point that connected to each other. So here we have what? We have EMF of the total EMF of each one of these dry cells is 2, for example. So the total EMF, if I have 100 of these dry cells, it's equal to also. Why? Because this is parallel connection. Here we have our circuit again, and here we have one cell, and after this we have one lamp. So here we have the investigating of parallel circuits. If I have increasing, or I increase the batteries to 2 cells, and I increase the bulbs like this, we have 2 bulbs. What will happen here? Here we have what? If I close this one, we have the electric energy that found in the 2 lamps. Why? Because they are parallel connection to each other. So the parallel connection, or the parallel circuits, we have the EMF, that's what? That's found in all batteries, yes, and it's found in all parts of the circuit, yes. Why? Because here we have what? We have the parallel circuits, they have what? They have distributing, or what? Or the first part of the voltage or EMF that move in what? In the first lamp, and the second lamp we have another part like this. So here we have what? We have 2 lamps here. That's what? That's parallel circuits. After that, if I increase the number of lamps like this, if I have 3 lamps here and I have the same amount of EMF, and I close this one, so here we have what? We have the light energy we have here, that's what? That found also. Why? Because here we have parallel connection of what? Of the lamp with what? With the electric dry cells. And if I have the cells, 3 cells and 3 lamps, okay, and I make on like this, so here we have the electric cells or the electric lamps here, that's what? That will be, or will light up. And here we have the ammeter. If I have a meter like this, what will happen for the ammeter if I put it here like this? Here we have many of these readings. Here we have 2.7, the total one, and this total amount of ammeters here. So here we have, this is distribution or classification, or each part of this 2.7. Here we have what? We have 0.9 in the first one, 0.9 in the second one, 0.9 in the third one, or third lamp here. Why? Because here the voltage or the electric current intensity that distributed in what? In the 3 lamps. And if I have voltmeter like this, voltmeter, it makes what? It makes 6 volts, 6 volts, 6 volts. Why? Because here we have what? We have 3 batteries here. The total EMF here, it's what? It is what? 6 volt. So here the voltage doesn't what? Doesn't distribute it here in each part of this circuit. But the electric current intensity, it makes division of each part of this electric current intensity that found in each part of the lamp here. So here we have what? We have the ammeter and voltmeter that makes reading of what? Of the ammeter that makes the electric current intensity reading is 2.7, so it is divided into 3 parts. And we have the voltage, it's what? It is equal each other. So we use this type of electric or parallel circuits in our homes. This video we will talk about electricity. Here we have what? We have the atom, and we have the nucleus of the atom that contains what? That contains the protons, and it contains what? Positive charge, and this protons is positive charge, and we have neutral neutrons that has zero charge. And here we have another thing about electrons. This is the source of electric energy, and the movement here that found between them due to the attraction force between the positive proton and the electrons here that move around the nucleus in an oval orbit or elliptical orbit like the solar system. So here this electron, it is movable one. And here we have the static electricity that we will talk about it in the first lesson. We have what? We have some amount of charges that makes what? That makes attraction by the balloon for what? For a pieces of paper that has a charges here. These charges, if you rub the balloon in your jacket that made of wool, that makes what? That makes attraction for a pieces of what? A pieces of papers. Another thing about electric energy, here we have what? We have a part of the sky that has the electric energy or static electricity that produced by what? By charges of lightning. Lightning, it comes out from the crashing between clouds, and it makes what? It makes this lightning here like what? Electric charges that found to make this light. And this is electric energy, and it is very dangerous to touch the surface of Earth. It will burn this piece or the area that fall down on it. So here we have, this is what? This is another thing about what? About the battery. It is a source of electric energy here that contains positive charge and negative charge. And this positive charge, negative charge, they are the source of electric energy inside the dry cell. After that we have these atoms that found in what? In the dry cell, chemical compounds to make what? To make the electric energy, and this electric energy, that's what? That's formed between the positive pole of the dry cell and negative pole of the dry cell. Here we have an electric circuit. This electric circuit, it makes what? It makes connection like this. We have one battery, we have the circuits or electric wires, and we have a lamp. This lamp, it makes what? It is light up because it has some electric current intensity that produced by the battery. So here we have the positive charge and negative charge, the negative one here and the positive one in the other side. So if I have the metals that are good conductors for electric energy to make electric wires like the copper, for example, it's very good one to make the copper here or to make the electric wires. And we have the battery here. Here we have the positive and negative charge. Here we have the positive charge and negative charge, the negative that move electrons through the wire to the positive one. Why? Because these electrons is movable particles, but the protons, they are not. Here we have what? We have the circuit that we use it to make series connection or parallel connection. If you cut out the wire, the lamp will put off or turn it off, and if you connect the wire, the light will turn on like this. And we have many buttons of our homes and our schools to make this what? To make this electric energy inside our homes and what? And schools. Here we have the electric circuits in what? In parallel connection. So here we have the parallel connection. Here it means we have the electric current intensity that divided into two parts to make what? To make electric current in two lamps here. Here we have the electric current intensity that move like this from the negative and move in the two lamps in the same time and move again to collect each other to the positive pole. So we use this parallel connection in our homes and our factories and our schools and hospitals. In every building we have what? We have this type of connection that called parallel connection. Why? Because I miss one of this lamp, the other one will continue its work, or it still lights up. If I move out or turn off the light from one lamp, the other one will be or will turn on and continue in its working. If I have many lamps like this, so here we have what? all the lamps will work very good in what? In the parallel connection. But here we have the series circuits. We have what? We have two lamps here. If you connect this one, we have light, and the electric current intensity that pass in the first one first, and the second one after that, and collect itself again to the positive one. If you miss one of them, or turn off one of them, or cut this circuit, the other one will not light up. Why? Because it's what? It is a series connection. If you move one of these lamps or open the circuit like this, so we have no lamps or no connection or no electric energy in each one of them. But in the parallel connection, we have what? We have the two lamps like this, and we have the light that's still found in the two lamps. Now we have some exercises about our lesson. We have, are these statements about resistance are true or false? Here we have the first thing. Thicker wires have the lower resistance. It is right or wrong? Thick wire has low resistance. It's what? It's true. Try to make this. We have true one. Yes, we have this is correction. Yes, is right. This is one. Why? Because what? Because I told you about, or before a period of time, we have what? We have very thick wire. It has low resistance. Why? Because the cross section of this wire is very, very high. Number two, we have the shorter wire have increased resistance. Have increased resistance. It's short wire. It's what? It's false or right? This is false, and we have correction. This is right. Excellent. Why? Because the short wire, it has what? It has increasing or have increasing resistance. After that, we have heating a wire increases its resistance. Heating wire increases its resistance. It is very right. It is true. Why? Because the heat energy, it makes what? It makes this one, or increasing of the resistance by increasing the heat energy. After that, metals that are good conductor from wires, lower resistance with low resistance. Again, metals that are good conductors from wires form wires with what? With low resistance. It's what? True or false? Try to make true, okay, and make the correction. It's very right. Why? Because the metals, they are good conductors of electric energy, and it has most amount